And now I'd like to invite Mr. Noam Perski, the Executive Vice President of Palantir Technologies. Mr. Perski will tell us about the new battlefield and the shift to software-driven warfare. Thank you. Mr. Perski, please.
All right. Where are we going to be? Up here? All right. Cool. Clicker. Awesome. I have slides. Exciting. Are they up there? No? There we go. Great to meet all of you. I'm Noam. The only Noam who doesn't speak any Hebrew really at all. I used to have this joke where I would come to Ben Gurion, or actually when I was leaving the country, that they would give me a hard time that I had an Israeli passport hidden somewhere, and that I was skipping out on reserve duty. I don't get that anymore with more gray hair and my beard, but so I will do all of this in English, and if you have any questions in Hebrew, I will not be able to answer. I wanted to talk to you a little bit about the revolution in warfare that's happening because of software, driven by software. But maybe before I do that, I wanted to spend a second on Palantir's role here. I've been coming here, building our business in Israel for the past 10 years or so, and I've never been prouder than I am now about our work here, the leadership of our CEO, Dr. Karp, our board, who convened here this year in February, our team on the ground here that has doubled since October 7th, our deep investment in Israel and our support for the country. It's very, very deep. It means a lot to us. It's very cool walking up here and seeing our logo next to Elbit, Rafael, and IAI, considering ourselves the fourth Israeli defense prime. It's pretty cool. And look forward to the rest of this journey. But I wanted to spend some time today saying a bunch of obvious stuff and then decomping that a little bit. So I guess the first obvious thing is that software doesn't win wars, right? The willingness of men and women to put their lives on the line, the willingness of parents to put their children in the line of fire, of leaders to make difficult decisions. These are the things that win wars. And one of the reasons I came to Palantir was about 13, 14 years ago, I went to Palo Alto and I met a bunch of people working on counterterrorism. And it wasn't this Silicon Valley naivete of we're going to build an app and solve a problem. It was like counterterrorism is a problem you work on, you don't solve it. And that sort of realism in an approach, I think, is really important as the defense tech ecosystem grows like crazy. We have all these new entrants, all these people who used to be tech bros are now defense tech bros, and it's all wonderful, and it's all AI, and it's all algorithms, but at the end of the day, the important thing is it is in service of the warfighter and people willing to put their lives on the line. And so we'll talk about software, but it's always, I think, important in our minds as we do this to forward deploy alongside the men and women again in the line of fire and remember that this is the core truth. Now, that said, I think obvious to everybody here that a modern war cannot be won without software. And seeing software as a defense system, as a weapon system, as the most malleable weapon system we have, I think is really important as we build the next generation of capabilities. So breaking this down for a second, why are we in this space and what does it mean? So the first thing for me is that we are in an era where combined arms are the only way to deploy. And not just combined arms, so we talk about JADC2, Joint All-Domain Command and Control. So if you want to deploy combined arms, you have to be able to command and control across all these different service branches, all these capabilities. But we're adding another C to it because we're not deploying on our own. We're doing that with partners. We're doing that in coalitions. And so how do we do joint efforts across all of this? We can't do that without great software. I mean, and it's very interesting to see things like the conflict in Syria right now, where you have a considerably ragtag group of fighters who are doing combined arms operations, right? And they're doing this because of great software. It happens to be homegrown and home built, and it's they do a lot of training. But at the end of the day, modern software capabilities give the ability to do true JADC2. We'll unpack that in a second. I think the second thing I'm going to talk a little bit about, the ability of software to help deploy hardware platforms from lots of different vendors from lots of different places, and what does that mean? And the third thing, I think, is how do we integrate the defense industry as part of all of this? So can we use software to sort of extend the conception of what it means to have a warfighting capability all the way to the factory floor? Because we're seeing a lot of trends, especially in the necessity to ramp up production, the move to much cheaper weapon systems where you need masses of them. That changes the way we look at these systems. So unpacking these for a second. So forget all these like points that are up here. I think the most important thing is that joint all-domain command and control and CJAD2 is actually happening now. And for forces that aren't able to do this or aren't doing it, you're in real trouble. The US military, where we've sort of grown up, we started working with something called Project Maven in 2019. Project Maven has morphed into something called Maven Smart System. If you haven't Googled it, do it. It is joint all-domain command and control driven by AI in deployment now. And it has gotten there not by some grand program that was started 15 years ago with this vision of doing joint all-domain command and control. It was MVP after MVP and iterating our way to a capability that is truly, truly incredible. I think there was an analysis, a public analysis that was done of Maven where they looked at the best targeting cell in Iraq that the US had working in Iraq was 2,000 people. There are 20 people now at CENTCOM doing the same amount of targeting as 2,000 people, right? So what does that mean when you're able to do that kind of a thing? It means you're able to put people against even harder and more important problems. You're able to process targets more effectively, and you're able to spend your energy working together. And that's what we're really seeing. So software gives us the ability to do this, right? Wonderful. Well, if that's happening, what are we doing it with? And I think this is the next thing that we're seeing, right? So we're seeing the ability to deploy not only one or two weapon systems, but multiple weapon systems. It's happening in the Ukraine, as been talked about this morning. The ability to deploy many, many manufacturers' hardware capabilities and stitch them together into something resembling a unified capability. And this is very difficult to hear if you're, my friends at a lot of the manufacturers that are here today. But this is the reality that we have to play with, right? And the reason this is so important is we're not quite sure what happens next on the battlefield. We can do a lot of planning, and in some theaters it plays out really nicely, exactly the way that we thought, and in some theaters it really, really doesn't. And you have to adapt. And the ability to throw different kinds of hardware at different kinds of problems and different kinds of effectors at different kinds of problems is really, really important. And we can do that if we have great software that's stitching things together. So this is sort of the software-enabled hardware idea is, can we decouple these things a little bit and then give us lots more choice? The adaptability element is really, really, really important because it forces also an interoperability. So a lot of what's really interesting with a lot of this like defense innovation stuff is that once you force a system to adapt, it does, right? So here, if we, using great software, are able to stitch lots of different types of hardware together, we're also giving ourselves the ability to work together. It gets us faster to JADC2. So if you're in this place where I have this exquisite piece of very expensive hardware, I have control systems for that expensive hardware, I have people that are trained to use that expensive hardware, and then I have a command structure that's used to that, you can see how you get silos very quickly. When you're in a world instead where I have software that lets me see across all of my capabilities and deploy the right capability in the right place, you can kind of see how it quickly gets you to a place where lots of people are working together. So if you want to force your organization to actually get to something like joint command and control, you use great software and lots of different systems because it forces the organization to actually adapt to that idea. And I think this is one of those like poorly understood and dirty secrets that a lot of the capabilities we're deploying are what then forces an organization to look like a bunch of silos. So if we change the capabilities we're deploying, we're also going to change the organization. And I'm pretty sure it's going to come that way as opposed to like trying to change the organization first. The third thing here that these heterogeneous hardware platforms, I think I put the word heterogeneous in there just because it's difficult to say on stage. And I'm going to have to say it a bunch of times. So, but the third thing here is arsenal depth, right? I'll come back to this on the defense industry stuff. But We look at the Ukraine where 10 years of artillery production were deployed in 10 weeks. That's a real problem, right? It's a real problem. And if you have exquisite weapon systems and you're very focused on being able to deploy those exquisite weapon systems, and you run into a situation like that, it becomes very hard for the organization to adapt. If you instead are used to the idea, look, we're gonna take different stuff off the shelf and deploy it, and we're gonna have people that are trained to be able to do that, and we have software that's able to adapt to this and enable this to happen, you have lots more optionality. And I think as a commander, you want optionality in this world, because you don't know if your conflict is gonna last 2 weeks or 2 years. We've been wrong about a lot of that over the last couple of years. And so the adaptability here and the depth of an arsenal, if you're able to deploy whatever you're able to produce, that gets really interesting. The last piece here is actually about something really boring. So if you're in a world where you're able to deploy all kinds of different technologies, all kinds of different effectors, because you have great software stitching it together, you have an organization that's trained to use different things and adapt to it, it also means you can change the way you buy stuff and develop stuff. So the last 30, 40 years have been about, we compete on paper, somebody wins a contract and then they go develop a system. Wonderful. That's actually not how we got ICBMs and the best programs, especially in the USDD, were built out of competition. You had many different programs that were competing, and the idea that, look, we're gonna deploy any of these that work and all of these that work. A competitive environment is exactly what gets us incredible capability in the commercial realm. You look at SpaceX, like a 200 times cheaper kilogram to orbit than pre-SpaceX. Why? Because it's a commercial capability competing on a commercial market. Our defense industry doesn't work like a commercial market. So can we make it look like a commercial market? The only way to do that is competition. The only way to get competition is to be able to say, okay, well, look, we want a new tank. We have to be able to field 4 or 5 different kinds of tanks. I know that's a bit ridiculous, but just putting a point on it, right? The idea is, if we can have a competitive environment, we're gonna get better stuff, and we're gonna have better things in the hands of the warfighters. To get a competitive environment, you need to be able to deploy lots of different kinds of capabilities. I'll leave it there, but I think this is an incredibly important point as we think about what kind of a defense industry we're building. Which gets me to this last piece. So if you look at Palantir, it's very easy to say, look, Palantir does a bunch of cool AI-driven stuff, JADC2, we're deployed in Intel, we're deployed in special forces, we're deployed in conventional forces, we're doing all kinds of cool stuff. Yes, I think the biggest impact Palantir is having right now on our ability to deter our enemies by building defense capability is actually in industry. So in the US, we're calling this warp speed, but we're working with Anduril, Shield AI, and a bunch of others, L3Harris and others, to ramp production using great software. And this comes from an insight that we had, I think a little while ago, our CTO, Shyam Sankar, that the defense industry in the US used to mean industry doing defense things. So if you look at the Second World War, we had Chrysler, we had Chevrolet, we had Oldsmobile building weapon systems, right? You look now at our world. In the US, we have a number of defense primes. Almost all of their money comes from producing defense systems. They're wonderful organizations that are great at producing these bespoke, wonderful defense capabilities. As we're moving into a place where you need to be able to field 100,000 drones rather than build 5 F-35s, the Chinese have a very different approach. So you have a number of organizations in China that are driving defense capability, that are doing defense manufacturing, that are really good at building things. And I've been to lots of defense production sites. They're very cool, but they all look like workshops, right? They don't really look like factories, most of them. And if we're in a world where we need to produce huge amounts of these capabilities, I think this is a very scary prospect. And so we need to move into a place where we can do defense manufacturing at true scale. Now, the only way the West gets there is through use of great software. So it seems a little esoteric, but I'll give you an example. So Panasonic North America, Panasonic, world's largest battery production company outside of China, built a gigafactory to build lithium battery cells in the US to supply Tesla and others. The only way that factory works is through use of great software. So we're deployed there because you need to take American workers, basically from that were in Las Vegas working in the casinos, and put them on a manufacturing line. And to do Japanese quality caliber manufacturing, basically overnight, the only way to do that is using AI and great software. Quality control, production scheduling, all of the things you need to do. You can't use Microsoft Project and like a 17-year-old version of SAP to do some production planning and then like hope that people will get this together. Not when you need to do this at scale and at speed. And so if we think about application of software and the change that software is bringing in the defense, in the world of defense, yes, all the fancy things that are happening on the commander screens, but I think all the way to the factory floor is the way we need to do this. Otherwise, we're missing a trick. In the US, this is happening in really, really, really interesting ways. So this is the Titan truck, forward-deployed intelligence node running a bunch of servers with SATCOM capabilities, lots of different capabilities. The prime contractor on this giant hardware project that's going to deliver hundreds of trucks is Palantir, a software company, which is really interesting. Why? Because the key capability here is the fielding of the software inside of the hardware. I'll round out, because my time is up. One of my favorite Danes, I live in Sweden. We're not supposed to like the Danes or the Norwegians or the Finns, but I kind of do, is Niels Bohr. I think anybody living in our world over the last 5 years appreciates this statement. So what does this actually mean for us, for a company like Palantir? It means that we're living in a world where agility is more important than the ability to predict the future. And if this is the case, which I believe very deeply to be true, our ability to be agile is more important than our ability to build wonderful things that are based on an idea about what the world might look like in 10 years. So for us as a company, for Palantir, what does this mean? This means that we've gone from building buildings, so we used to deliver these wonderful capabilities to the warfighter, to intelligence agencies, to the commercial industry. We have basically, over the last 2-3 years, pivoted to the idea of like, we need to build capability that lets people build things because we don't know what you're going to need. So for our Ukrainian colleagues, they didn't know they needed to be able to do deep strike drone attacks in the world's most contested electronic warfare environment. We didn't know that 3 years ago. You need to be able to build that basically overnight. And if you don't have the building blocks for that, it takes way, way, way too long. So from our perspective, we've done two main things. One is our platforms basically let you build overnight against your entire base of data, your entire base of systems, and it's changing the way we deliver capability. The other thing is this thing we're calling Mission Manager. So we invested millions and millions of dollars and many, many years building the most secure infrastructure for deploying software capabilities inside the US DoD and other places. And we've now opened that up to startups and other companies. And so we have 60 or 70 companies now running on Palantir infrastructure, delivering algorithms and other capabilities to the US DoD and to partners without having to go through all of that process and rigmarole. So, which means you can, if you are a commander and you see a capability you need, you can get it in 2 or 3 days as opposed to 3, 6, 9, 12, or 24 months, because we're building on top of this infrastructure. And so I think just to close out here, the idea that you don't know what you're going to need, so you need to build with that in mind. You need to build a set of capabilities that lets you get whatever you want to the warfighter very fast. And our view is the way to do that is to use software to stitch everything together. That's what we're trying to do everywhere in the world, especially here with great partners in industry, great partners at Mafat, great partners within the IDF and other places. And I couldn't be prouder to be up here talking about all of this and looking forward to working with all of you to make this a reality here. Thanks.